there is new research done by Stanford on productivity with AI, and it's way better than the previous one. So last week I talked about a survey that came out that said engineers thought they were 20% more efficient when in reality they were 19% less efficient. That was only done on 16 people. As you'll see as we walk through this one, they covered a lot more, and it gives you some pretty interesting info around what they've found, what works, when it makes sense, when you should use AI and when you shouldn't. So it's actually, I think it's pretty darn good. I'm pretty happy with it. So I want to just watch it here with everybody on stream. Let me get everything lined up nice and pretty, and we will go.
In January of this year, Mark Zuckerberg said that he was going to replace all of the mid-level engineers at Meta with AI by the end of the year. I think Mark was a bit optimistic, and he was probably acting like a good CEO would to inspire a vision and also probably to keep the Facebook stock price up. But what Mark also did was create a lot of trouble for CTOs worldwide. Why? Because after Mark said that, every single CEO in the world almost turned to their CTO and said, hey, Marcus says he's going to replace all of his developers with AI. Where are we in that journey? And the answer probably was honestly not very far. And
I can confirm, as a CTO, that did happen. And that has happened multiple times for me, as since I run a fractional CTO business, I get a ton of people reaching out, asking me this exact question. What should we do? How should we be doing this? And why aren't we doing it? There's a lot that goes into that. But this is some good information for those of you that are in this situation, whether you're the CTO, the VP, you're just an engineer, and someone's like, hey, what are we doing with AI? This will give you some backing. This will help you build a framework around what you should do, where it makes sense, when it makes sense, and when it doesn't make sense.
And we're not sure we're going to do that. And so I personally think, hopefully this is not, gonna change, but I don't think AI is going to replace developers entirely, at least this year, let alone at Meta, right? But and I do think that AI increases developer productivity, but there's also cases in which it decreases developer productivity. So AI, or using AI for coding, is not a one-size-fits-all solution, and there are cases in which it shouldn't be used. And so,
all right. So that sets the stage, and there's some really good data that is backed up within this whole story that he walks us through. But that's the reality. There never has been a silver bullet for anything, be it you want an agile framework, or you want a technology, or you want anything. There is no one size fits all, and AI is exactly the same way. There's times where it's great. There's times where it's not. You have to engage your brain and figure out if you're in one of the situations where it makes sense to use it. And then if it does make sense to use it, you have to engage your brain again and decide how you're going to use it. So there's a couple places where you can't just be lazy and say, we're going to go AI. You have to be intentional and thoughtful about it. This video will walk you through a little bit of the things that help you figure that out.
So for the past 3 years, we've been running one of the largest studies on software engineering productivity at Stanford. And we've done this in a time series and cross-sectional way. So time series, meaning that even if a participant joins in 2025, we get access to their Git history, meaning we can see trends of data across time. We can see COVID, we can see AI, we can see all of these trends and things that happened. And then also cross-sectional, because we have more than 600 companies participating, enterprise, mid-sized, and also startups. And so this means that we have more than 100,000 software engineers in our data set right now, dozens of millions of commits, and billions of lines of code. And most importantly, most of this data is private repositories.
All right, so already this is massively more valid than the 16 developer one that came out last week, where if you follow my TikTok or anything, I mentioned that, I talked through that. But this one, hundreds of thousands of engineers, 600 plus companies, that's real valid data.
It's important because if you use a public repo to measure someone's productivity, that public repo is not self-contained. Someone could be working on that repo on the weekend or once in a while, right? Whereas if you have a private repo, it's much more self-contained and much easier to measure the productivity of a team, of a company, of an organization. So late last year, there was a huge controversial thing around ghost engineers. So this came from kind of the same research group, our research group, and Here, Elon Musk was kind enough to retweet us, but what we found is that roughly 10% of software engineers in our data set at the time, about 50,000, were what we called ghost engineers. These people.
Okay. Does that number surprise you? Does the concept that 10% of the engineers that they tracked effectively created zero value, does that surprise you or not? If it doesn't surprise you, then what that likely means is that your team needs to do a better job of what I call either leveling up or leveling out. So if you have some folks that aren't able to level up and stay with you and grow and make a difference, then they've got to be leveled out. You have to do the hard work of realizing that they're not helping. So you need to do the hard work of removing them from the team and finding somebody that does move the needle. Unfortunately, there are too many places that just continue to let this happen. So hopefully you aren't one of those companies. If you are one of those companies and you need help, let me know. I help with that quite often. It's a common problem. I don't enjoy it, but it's a thing that once it's fixed at the end, everybody feels a little bit better because like, oh man, we got the team we need. So hopefully you're not in this situation, but if you are, reach out, let me know, and we'll see how we can help.
People collect a paycheck, but basically do no work. So that was very surprising for some people, very unsurprising for others. And so some of the people in this research team are, for example, Simon from industry. So he was CTO at a unicorn, which he exited. And he had a team of about 700 developers. And as CTO, he was always the last person to know when something was up with his engineering team, right? And so he thought, okay, how can I change this? Myself, I've been at Stanford since 22, and I focus on what I call data-driven decision-making in software engineering. And in a past life, I was looking after digital transformation for a large company with thousands of engineers. Part of the team is also Professor Kaczynski, who is at Stanford, and his research focuses on human behavior in a digital environment. And basically, he was the Cambridge Analytica whistleblower back in the day, if you recall that. So today, we're going to be talking about three things. We're going to start off with the limitations of existing studies that seek to quantify the impact of AI on developer productivity. We're going to showcase our methodology. And lastly, we're going to spend most of the time looking at some of the results. What is the impact on AI on dev productivity, and how are ways we can slice and dice these results to make them more meaningful? And so there's lots of research being done on this topic, but a lot of it is led by vendors who themselves are trying to sell you their own AI coding tools, right? And so there's a bit of a conflict of interest there sometimes. And the biggest three limitations that I see is that a lot of these studies revolve around commits and PRs and tasks. Hey, we completed more commits, more PRs.
This next section is fantastic. It's how I knew that, okay, this study actually is valid. They actually spent time understanding what metrics matter. As he's going to talk about is the PR tools, the code review tools that are out there. They are trying to say, hey, the more you do a thing, the better you are. That's not always the truth. And he's going to talk through that here. So again, this is one of those things that as I watch this, I'm like, this is the kind of study that we need. This has some real valid data in it. So, okay, back at it.
The time between commits decreased. The problem here is that task size varies, right? And so delivering more commits does not necessarily mean more productivity. And in fact, what we found very often is that by using AI, you're introducing new tasks that are bug fixes to the stuff that the AI just coded before. So by that case, like you're kind of spinning your wheels in place, right? So that's kind of funny. Secondly, there's a bunch of studies who say, well, we grabbed a bunch of developers, we split them into two groups, and we kind of gave one AI and one of them we didn't. And what usually happens there is that these are kind of greenfield tasks where they're asked to build something with kind of zero context from scratch. And there, of course, AI decimates the non-AI people. But that's because AI is just really good at greenfield kind of boilerplate code, right? But actually, most of software engineering isn't greenfield and isn't always boilerplate, right? And so there's usually an existing code base, there's usually dependencies. So these studies can be like applied too well to these situations either.
Okay, so there's two key points there I want to talk about. Number one, more commits doesn't mean more better. They actually talked about some of the data that they'll show later shows that using AI causes you to commit more often, and actually some of those commits are cleanup from the work that AI got slightly wrong that you find later. So yes, there's more commits. Yes, they happen in fewer time frames, but it's not always value added code. Second, I can speak to this, I'm with the app that I'm building right now. It is 100% true that AI can quickly spin up the boilerplate common things that are needed for you to get the party started. But once your product starts to get to a volume where there's enough complexity, that's where the context windows start to break down. And there's some more data later in this that we'll watch and listen that he really starts to explain that. So more to come.
And then we also have surveys, which we found to be an ineffective predictor of productivity by doing this small experiment with 43 developers, whereby we ask every developer.
This is one of my favorite parts because I've been posting 4 TikToks, Instagram, YouTube shorts a day, talking about what I've learned while doing AI across the board. And the number of people that jump in the comments and say like, you don't know what you're doing, bro. I'm like 20 and 30x. Well, let's watch and listen.
To evaluate themselves relative to the global mean or median in 5 percentile buckets from 0 to 100. And then we compared that to their measured productivity. We'll get into what that means later. But what we found is that asking someone how productive they think they are is almost as good as flipping a coin. There's very little correlation, right? And so we found that people misjudged their productivity by about 30 percentile points. Only 1 in 3 people actually estimated their productivity within their quartile, 1 quartile. And I think surveys are great. They're valuable for surfacing, morale and other issues that cannot be derived from metrics. But surveys shouldn't be used to measure developer productivity, much less the impact of AI on developers.
So for those of you out there that are on the no estimates bandwagon, this should fit clearly into that stance. I like estimates. I think there's value in coming up with the estimates, not because of the estimate itself, but it helps the team have the discussions that are necessary for you guys to unlock what this feature is or isn't and get to clarity and consistency on what we're actually being built. What the estimate is, what the size is, doesn't matter. The estimate's just a tool for you to get to a spot. As he talked about, most people, when they estimated their productivity, weren't even within their quartile. So they weren't even with their 25% range of what they actually were. So as he said, people telling you, estimating how their productivity was affected by AI is effectively a coin flip. Half the time they're right, half the time they're wrong.
For productivity cases, you can measure it to kind of see how happy they are using AI or whatever, I suppose. Great. So now let's dive into our.
He was very reluctant with that last bit around, I suppose you could. So let's go back and listen to this as he talks about using a survey to measure how happy you are. He throws it in like, I suppose. Like he felt like he was obligated to say that, but you can tell that the scientist within him didn't want to really admit that, but he just did.
For productivity cases, you can measure it to kind of see how happy they are using AI or whatever, I suppose. Great. So now let's dive into our methodology. So in an ideal world, you would have an engineer who writes code, and this code is evaluated by a panel of 10 or 15 experts who separately, without knowing what every person is answering, evaluates that code based on quality, maintainability, output, how long would this take me, how good is it, right? So kind of like a bucket of questions. And then what happens is that you aggregate those results, and we found 2 things. The first one is that this panel actually agrees with one another. So it turns out that one engineering expert agrees with the other engineering expert when they're talking about an objective code in front of them. And secondly, and probably most importantly, is that you can use this to predict reality. And reality is predicted by a panel like this.
So this is a reason why I believe the quality of AI code generation is going to improve, because he just talked about how they were able to consistently have experts evaluate the quality of code. So they were able to consistently say, this is what good quality code looks like. And he'll talk about in a minute here how they put that into a model. So they were able to model that. So that increased quality is coming because, as Stanford has proven here, it's 15 people, right? So again, grain of salt with what we expect to come out of this, but this is an indicator that we're going to be able to make it better. I still, just as he does, I still don't see a world where human developers aren't needed. I just don't see a world where that happens. And I, hope I'm not wrong there, but we'll find out.
The problem then is that this is very slow. It's not scalable. It's expensive. And so what we did is we built a model that essentially automates this, correlates pretty well. It's fast, it's scalable, and it's affordable. The way it works is it plugs into Git, and then the model analyzes the source code changes of every commit and quantifies them based on a bunch of these dimensions. And then since every commit has a unique author, a unique SHA, a unique timestamp, then you can kind of understand that, okay, the productivity of a team is basically the functionality of the code they deliver across time. Not the lines of code, not the whatever commits, but like what that code is doing, right? And so then you can kind of put this in a dashboard and overlay it across time and get something similar to this. Great, so now let's dive into some of our results.
What everybody's been waiting for.
So here in September is when this company implemented AI. This is a team of about 120 developers, and they were piloting whether they wanted to use AI in their kind of regular workflow. And we have here these bars, and every bar is the sum total of the output done in that month using our methodology, not lines of code. And we can see that in green, it's added functionality. In gray, it's removed. In blue is refactoring, and in orange is reworked. And so rework versus refactoring, they both alter existing code, but rework alters code that's much more recent, meaning it's wasteful. Refactoring could be wasteful, could be not wasteful. And so from the get-go, you see that by implementing AI, you get a bunch more of rework. What happens is that you feel like you're delivering more code because there's just like more volume of code being written, more commits, more stuff being pushed. But not all of that is actually useful.
This dude just nailed it. Without a doubt, a team's capability to generate more lines of code goes massively up. But we all know more lines of code doesn't mean the product is better. Oftentimes it makes the product worse. How many teams, how many senior engineers, architects, or whatever have you worked with where they've talked about how they value removal of lines of code versus addition of lines of code? AI makes that worse. And this is hardcore data that shows you there is this orange he labeled as wasteful work. So they are reworking things. So there's a massive jump in the rework that is needed. Now, the green is also the added value. The added value does go up here. He doesn't talk about that as much as I would like him to, but overall, those green bars are bigger. So it's easy to see that, yes, AI helps you create more value, but also it requires you to do more cleanup. I mean, I think those of you that have been using AI effectively, you kind of feel that. Like, yeah, there's times where I can get some more done, but also there's some times where I feel like I'm just spinning my wheels and I'm redoing stuff that I shouldn't have to redo, and it's annoying. You start to question, should I be doing this? Should I be using AI? Oh, this is harder than it needs to be. So here's some data that's confirming that.
To be clear, I think based on this chart and overall, there is a productivity boost of about 15 to 20%. But then a lot of the gains you're seeing are basically this kind of rework, which is a bit, misleading. So if I could summarize it into one chart with many discrepancies, it would be something like this. So with AI coding, you increase your productivity by roughly 30-40%, right? You're delivering more code. However, you got to go back and kind of fix some of the bugs that code introduced and kind of, fix the mess that the AI made, which in turn gives you an average productivity gain across all industries, all sectors, everything, of roughly about 15 to 20%. There's a lot of nuance here, which...
Okay, still, all the noise, everything that goes out there. Here's data backed by hundreds of thousands of developers. That's a year old. So this is through August of 2024. And we know it's gotten better. So using the technology from a year ago, they tracked over 600 companies, over 100,000 developers, and found that on average, they were 15 to 20% more effective. Yes, there's some noise, there's some other things in there, but this is hardcore data that says you're going to be 15 to 20% more effective using AI. That's not so bad. That's pretty good. Is it Game changing, life altering? No. But 20% gain is pretty darn good.
We're going to see in just a second. So here we have two violin charts. And
by the way, did anybody know before he said this that this was a violin chart? When I watched this yesterday, I had to rewind it. Like, what did he just call that? I had no idea, that there was such a thing called a violin chart. And if you asked me to draw a violin chart, never would have known it looked like this. Kind of makes sense, I guess. But hopefully you guys are smarter than me, so you guys knew what that was, right? It was news to me.
And they plot the distributions of the gains in productivity from using AI. And so kind of like the y-axis is the gains. It starts from minus 20%, take note, and then it goes up. And here we have kind of 4 pieces of data being shown. In blue is low complexity tasks. And in red is high complexity tasks. And kind of like your left, the chart to the left is greenfield tasks. The chart to the right is brownfield tasks. So right from the get-go, the first conclusion we have is that, sure, it seems like AI performs better in coding with simpler tasks. That's good. It's proven by data. That's awesome. The second thing we see is that, hey, it sounds like for low complexity greenfield tasks, there is a much more elongated distribution and a much higher distribution on average. Keep in mind that this is for enterprise settings. This doesn't apply for kind of like personal projects or vibe coding something for yourself from scratch. The improvements there would be much bigger. This is kind of for like real world working company settings. And the third thing we see is that if you look at the high complexity tasks, I mean, they're lower than the low complexity ones on average in terms of the distribution, but also in some cases, they are more likely to decrease an engineer's productivity. Now, this decrease could be for many things, many reasons, but that's kind of what we see in the data, right? The underlying causes are still not.
Also, a key point that he talked about earlier that he'll hit a little bit here, but most of us don't work in a greenfield world. Most of us work in some enterprise software setting where the product has been around for quite a while. So that means we need to, yes, the chart on the left is nice, interesting, but that only holds true for the first month. If you have a team building a greenfield app, how long is it greenfield before you have enough momentum that now it's brownfield and that's big enough? And that comes up later. He has charts and plots over certain number of lines of code.
Not super clear to us. If we translate this to a chart like this, which is a bit more digestible, you have in the bars and the columns, kind of like the average or the median gain, and then the line represents the interquartile range. So the bottom of the line is the 25th percentile, and the top of the line is roughly 75th percentile. And so here it's very clear to see how we have more gains from low complexity tasks, less gains from high complexity tasks, and then brownfield, it's harder to leverage AI to make increases in productivity there compared to greenfield.
So the point this drives home for me is something that we've been trying to do forever. Regardless of AI, we've always known, we've felt it, we've seen it, we've lived it, where if you can break your work down into smaller, digestible chunks, it's easier for you to do that work. We've known it, we've lived it. AI just highlights that and really shoved it in your face of, you know what? Teams that are good at product, teams that are good at breaking down stories, breaking them into smaller, consumable, self-contained work, you're going to be more effective. Whether it's you doing the work, a third party you're handing it off to, or AI, those same patterns and practices still hold true. If you want to be a great development team, be great at product, be great at breaking work down before you start at it. That hasn't changed. It clearly won't change.
So if there is maybe a slide that you could show to your leadership team, it could be this one, or it could also be this one. So here we have a matrix, really simplifying things. Reality is a bit more difficult than this, but here we have kind of on one axis, task complexity, low and high. On the other one, project maturity, greenfield versus brownfield. Kind of we see that, hey, low complexity, greenfield, 30 to 40% gains, right, from AI. High complexity, but greenfield, more modest gains, 10 to 15. Brownfield and low complexity, pretty good, 15 to 20%. And most importantly, high complexity brownfield tasks, 0 to 10%. These are orientative guidelines based on what we see in the data. And I forgot to mention, this slide has a sample size of 136 teams across 27 companies, so pretty representative. And then that's kind of derived, or this chart is derived from that data. Then here we have a similar matrix, except at the bottom we have language popularity. So in low, we have examples such as COBOL, Haskell, Elixir, really kind of obscure stuff. And high is things like Python, Java, JavaScript, TypeScript. And what we see is that AI doesn't really help even with low complexity tasks for low popularity languages. It can help a bit, but it's not terribly useful. And what ends up happening is that people just don't use it, because if it's only helpful 2 times out of 5, you're just not going to use it very often. What's funny or interesting is that for low language popularity and complex tasks, AI can actually decrease productivity because it's so bad at coding in COBOL or Haskell or Elixir that it just makes you slower, right? Granted, this happens, but it may be 5 or 10% of the kind of global development work, if that. Most of the development work is probably somewhere in the high language popularity kind of part of the chart. And here you have gains between 20% for the low complexity and 10 to 15% for the high complexity.
This is no different than if you go to Stack Overflow or you do any research. You're going to be more effective finding answers at the more common, widely used tools. Not shocking. It's, again, those of you that have operated in some of those less popular tools, it's harder to get help. So this, it's the same thing. It translates just as you would expect.
So now moving into something a bit more theoretical, less empirically proven, but more so kind of like what we're seeing in the data, right? This is like an illustrative chart, which has kind of productivity gain from AI on the y-axis and a logarithmic scale of the code base size, right? From 1,000 lines of code to 10 million on the x-axis. And we see that as the code base size increases, the gains you get from AI decrease sharply, right? And I think most code bases nowadays are kind of somewhere in the, depending on your use case, right? But they're...
Let's take a look here. Let's look at my product that I've been working on here. We've got an easy way to see lines of code. Let's give this a shot. All right, so I'm at 65,000 lines of code. Is that pulling in? That's ignoring. Yeah, okay. So I'm at 65,000 lines of code. So I'm right here. I've been working on this app for like 2 weeks, and I'm at 60K lines of code. That seems like a lot. Ugh, I'm not sure how I feel about that. But it doesn't take very long to get to this massive dip. It doesn't take very long for your product to quickly reduce the value that AI provides. Yes, you get up here 60%. It's increasing your productivity by 60%. But then it drops pretty quickly because it's not going to take you long, especially using AI to get to 50, 60,000 lines of code and then around 100,000 lines of code. It's not going to take you very long because your productivity is so much faster at churning out that boilerplate starter code that just has to happen.
You're bigger than 1,000 lines of code unless you are a YC startup or something that's like kind of spun out a couple months ago, right? And that's because, there's three reasons for this, really. Context window limitations. We're going to see in a second how performance decreases even with larger context windows. The signal to noise ratio is kind of confuses the model, if you will. And then, of course, larger code bases have more dependencies and more domain-specific logic present. And so then borrowing work from this paper called Nolima, which shows you on a scale of 0 to 100 how LLMs perform on coding tasks, you see that as context length increases from 1,000 to 32,000 tokens, performance decreases. And so we see all these models here. For example, Gemini 1.5 Pro has a context window of 2 million tokens. And you might think, whoa, I can just throw my entire code base into it and it's going to retrieve and code perfectly, right? And what we see is that even at 32,000 tokens, it's already showing a decrease in performance from 90% to about 50%, right? So what's going to happen when you move from 32 to 64 or 128? Right? You're going to see...
Watch this. Yes, the context windows that they offer are massive, but as you see, it doesn't take very long before the capability of the model. Yes, the context window is bigger, but that doesn't mean it can be effective with it. So sure, it can accept more context, but it still struggles to use that context effectively. Just because it has more, again, just like we talked about, more lines of code doesn't mean more better. More context clearly doesn't mean that it's more effective. It can handle more, but it quickly drops off at how effective it can be just with like a tenth of the overall context window that it has. So be thoughtful about that when you're building your products, when you're doing your context engineering, prompt engineering, whatever you want to call it. Be thoughtful that even though the total possible context window might be huge, still fight really hard to keep the actual context you're asking the LLM to use, fight to keep that small. That will increase the likelihood of success.
Really, really poor performance here. And so in short, AI does increase developer productivity. You should use AI for most cases, but it doesn't increase the productivity of developers all the time and equally. It depends on things like task complexity, code base maturity, language popularity, code base size, and also context length. Thank you so much for listening. If you'd like to learn more about our research, you can access our research portal, which is softwareengineeringproductivity.stanford.edu. You can also reach me.
All right. So overall, that is a much more effective study than the one that came out a week or so ago that was only covering 16 developers. Even some of the smaller data sizes that they had were like 136 teams across 27 companies. Massively more data to validate their assumptions. Some really good data in there. So number one, thank you, Stanford, for doing that work. That is exciting to see, validating some of those thoughts and theories and some interesting points. So glad we covered that.